Thank you very much. Welcome to all to our talk, which is about one of the biggest questions, I guess, facing humanity. How can we meet the needs of the people in harmony with the needs of the earth? By 2050, there will be 10 billion people living in the world. According to the FAO, we need 50% more agriculture production, so the challenges are obvious. Agriculture must feed more people and do so more sustainably. And in this talk, we get now to know two fantastic pioneers of agriculture high-tech future. Our topic is breeding with smart light. Can the net zero greenhouse feed the world? So the plan of these two guys contains smart light, net zero, and greenhouse. Sounds like a miracle, but you will explain it to us. And so, let's start. Before we turn our attention to the future, I'm first interested in the question of where we come from. Alex, you grew up on a farm, and in the 1960s, there were almost 5 million farms in Germany, now less than 1 million. One farmer used to feed 8 people, today it's 59. So do you sometimes think wishfully about your childhood farming? And why can't we just step back and keep producing like we did when you were a kid? In harmony with nature, locally, more humble. Yeah. Why not?
As said before, the population is growing up to the 10 billion. Mm-hmm. The arable land is going down. We see what happens outside, both really by storms, erosion. So it's really under pressure. Then we see the climate is not really able to control. So the question is how much of food can be produced in different ways. We will not go away totally from arable land, but what we can put into farms and bring them more locally will help a lot to, with the limited resources we have, water, land, we have energy, to make it more sustainable, more closer to the need where the food is needed or the crops are needed to harvest.
Now, there's no elephant in the room, but a huge machine, which looks very funny, but nice with the lettuce. You brought it with you. So could you explain what it is about this innovative device?
Yeah, that's a nice collaboration, and that's where we see us also acting here as German Mittelstand, as we're Würth Elektronik belonging to the Würth Group, where we say we need to bring innovations onto the market, we need to collaborate. We need partners helping us. So the machine we see here contains mostly of 2 sections. One section, you allow me to stand up, okay, is the so-called fluid control, which we have here, and we are not the experts, right? So we did find a partner from Burkhardt here in Germany, because here we can now do things we can't do as a specialist for LED lighting, which is up there. And when we talk about LED, these are the nicely colored things here. LED stands for light-emitting diode. That's a very efficient way to generate out of a voltage and a current a specific wavelengths, also color, in different intensity, with low energy input and long lifetime. That comes on top. Further lamps were used, we call it stupid lamp, using a lot of energy, a lot of heat, so I can go here. Nothing happens to my hand, it's not burning my hand. So that's a good sign for high efficient. High efficient means less power usage. The most you can get out of your power input brings most power to whatever is needed on the other side. Here it's light and light intensity, high efficient. And now in the system with the fluid control, precise lighting control. We have now it's not fully closed here, we have to show you in case you something, otherwise we won't see it. In a closed system, we have now the ability to control and measure each of these parameter set, make it now measurable and usable now for what we need on top of it to learn from the system. Also even AI approaches come on top of this. Now it's possible to do so.
Okay, thank you. That sounds great and looks nice. But actually, Würth Elektronik eiSos produces electronic components, doesn't it, for the electronics industry? So what drew you to plants and why did you focus on LEDs? What can they do better than sun does?
I come from a farm, I know how hard it is now to produce in the right amount the crops you need, and how hard it is to predict the outcome from my doings on the field or in my farm. So the LED light especially when you talk about sun, yes, you can still use sun for growing plants. It's even used in many greenhouses, but for the plant, it's not so important to get the full white light. Each plant has its own, let's say, sensitivity to light and color, and this can trigger the speed of growth or the vitamin content I bring in or nutrition I can bring in. So I don't need the full light spectrum, I need a selected light spectrum. I have to understand how the plant is growing over time, not to do too much on the plant. Yeah, a salad needs to sleep sometime, yeah, in a different time than a tomato, so to say. And on top of it, of course, the fluiding control. But the LED itself, that's very interesting. Each and every crop has a different light recipe, a so-called technology, daylight integral needed to grow under the optimum. And that's not really explored on all of these plants. We have only roughly about, one say it's about 60, the other say about 200 plants already researched on this factor. So then in the machine later on you could load this light recipe, and then as a farmer I have it easy to begin, or a grower, to make this plant best efficient growing.
And it doesn't change anything about the taste. It's still nice. We could try it.
You can don't try it. No, you can even put more nutrition or more content of vitamins or whatever inside there. Yes, you can a bit modulate how it's really tasting. So from the water tomato tasting to really tasting tomato, and natural, again, fully natural. That's not a thing you do and override the plant. It's how you really give which nutritions at which time, which intensity of light. That makes it. That makes a difference.
When I prepared for the talk, I just Googled your name, Ryan Archer, and I saw that your startup, Horizon Growers, is a global pioneer in the field of CEA, which means Controlled Environment Agriculture. But then, in 2018, you achieved the global first agricultural production in the Abu Dhabi desert. And I asked myself, why did you try to get tomatoes out of the desert? Does it make sense?
Yeah, good question. Really, the motivation originally came from the self-sufficiency rate in the Emirates. It was very, very low. They had an exceedingly high rate of import. So ultimately, there was a market opportunity because consumers in the Middle East, just like here in Europe, they want a local product. And of course, there was the challenging aspect that it had never been done before. So to grow tomatoes 365 days a year when it's 50 degrees outside in a water-stressed region, that was also an opportunity and a challenge. But when you ask me whether or not it makes sense or not, it does. But what really didn't make sense was we went halfway around the world and actually identified that the import rate of tomatoes here in Germany is almost identical to the import rate in the United Arab Emirates, which was, that was the part that probably didn't make sense when we have the opportunity to grow local produce here in Germany or in the UK and lower that rate of import and increase our self-sufficiency.
Could you give us an insight into the international compare? So now you and your team have this vision of the first CO2 neutral indoor farm in Germany. What is it about, and how is Germany compared to other countries like the Netherlands or Spain or the US? I don't know.
Yeah, so if we were to go to a supermarket right now and go and look to buy a tomato or a cucumber, it's very likely that that product will have come from either Spain, North Africa, or the Netherlands. And if it had come from Spain or North Africa, it wouldn't have been reliant on fossil fuels, but what it would have been reliant on is a huge amount of water. And when you're shipping a ton of tomatoes from North Africa here to Munich, you are shipping a ton of water, but what you're also not taking into account is all of the water that was necessary to grow that tomato in an arid climate. So although they can benefit from the heat, they really struggle from the fact that there just isn't enough water. Now, if that tomato had come from the Netherlands, the way they would have been able to warm that greenhouse is by burning natural gas. So much so that the Netherlands burns over 3.5 billion 3.5 billion cubes of gas on a yearly basis just to heat greenhouses. And we just don't believe that's sustainable. If you were to continue in that direction, you would be interpreting that climate change can go on pause and our fossil fuels will renew themselves, which it's just not going to happen. So with Horizon Growers, we firmly believe in the asset class of controlled environment agriculture. We know that this and greenhouses are the future. What we want to do is do it more sustainably and be able to give consumers what they want, which is a local sustainable product, but then also provide supermarkets with what they want, which is sustainable supply at the right levels throughout the year in the right quality.
Alex, can you explain a bit more into detail what the role of the breeder here is within the farm of Ryan and what exactly happens in the greenhouse?
Okay, yeah, the most important point for every grower is from my seeding to get the maximum then later on as the crop coming out of the seeding. So each farm, wherever you go, has somewhere a nursery or a breeding station, so to say. And nowadays they're normal stations, not really high-tech stations, we would say. So, but the outcome is the output is not efficient enough, we call it. So eventually 60-70% out of my seedlings get really to crops.
Okay.
So you lose 30%. Under manufacturing aspect, you don't like this. You want to have yield rates 90, 95 and more. So we do with other components, right? And we said, how can we break this? How can we help to make it more precise? We call it about precision farming here, and measurable, that I said before, and learn from these all together. What we can do on other components we do in our factories, we can do this, right? How do we transfer this knowledge into precision farming? Yeah? And so the breeder is really the starting point for getting more output in the full supply chain from seed to plate. So if this station brings out of 70%, 95%, me as the farm operator earn more. That's clear.
Okay.
And then, of course, it has to be transformed in the right farm setup, as you described, about getting overall then the next achievements of more output from that. But that is really what this thing is doing here with the right nutrition levels, measurable and reconfigurable, so we can really do what you have to do and reconfigure any new, let's say, crop you do in a second.
So the light of the LED technique is crucial for the growing process. But as you showed us, there's no heat. So Ryan, where will it come from if production should not emit any CO2?
Yeah, so heat is an important component when growing any produce, especially if you want to do it in climates such as we have here in Germany or in the UK or even in Scandinavia. Even in the Middle East, we required heat to grow our plants. Now, fossil fuels are not sustainable. We can't continue to burn gas. So what we believe is that if you partner with industry, you have the opportunity to capture waste heat from industry and channel that into controlled environment agriculture. For example, here in Germany, we have over 190 petajoules of waste heat available from industry. And listening to the other panelists this morning talk about artificial intelligence and data centers, we know that we have to increase the quantity of data centers to deal with the AI compute, LLM compute, all these technological advances that we know are coming. But one of the challenges is those data centers come with a lot of heat. And we know that we can capture the waste heat from industry, convert that into usable heat in a controlled environment and use it to grow sustainable produce, not reliant on fossil fuels, remove the volatility from production, and then again give consumers the produce year-round in a sustainable way, close to home, where they can consume the product.
So this CEA setting, controlled environmental agriculture, is intended for growing seedlings that I then put into the field. Is it conceivable that at some point the entire production from seeds to harvest, so from the seed of a pineapple to a huge one, could take place in such smart greenhouses? And how many do we need to organize our supply in Germany?
And how many you will reply, right?
You can both answer.
Okay.
Yeah.
We, at this stage, we don't say everything has to be in a controlled environmental agriculture farmhouse. Yeah? But what we can implement there, we should implement and bring then the demand or the supply to the customer, very close to the customer. And the funny story out of this is when you get it really coupled together, the breeding station intelligent, loaded, then the farm coupled to this, and then you can even bring it very close to the customers and more on demand. So you can only grow what you need to grow. And by this, reduce also the food waste, which is also a great portion, the numbers in between 25 to 35% food waste. And this is also the other vision of controlled environmental agriculture, CA, robotic farming, with more logic and more AI loading, coupling to the customer on the other side, to bring those things into that chain, which is a bit more self-regulating and on demand locally, and with, of course, less use of water. We talked about the 700 how many? 720,000 tons?
I think so, yeah.
Many people get the misconception. They say, but it's only 720,000 tons in the tomato. No. If the water is not reached the tomato, and it's only 30% or 10%, depending on where you are, let's stick with the 10%, then it's 10 times more water you have applied on a field and not in the tomato. Yeah. So this is here totally different, because in this environmental closed thing, the water is circulating, gets reconfigured, the water, cleaned up again, UV disinfected. So you can really a lot of things do in that machine before you have to load then the water, ideal case for that what you need to grow in the system, and even further optimization. So first of all, it's not about to put everything in there. It's about what to put in there, what makes sense, and then with the arable land then getting free, we don't have to deforest. We can use it for different things.
Okay.
I think it'll be a while until we see a pineapple, but there's no reason why we shouldn't be having lettuce, tomatoes, strawberries, cucumbers produced sustainably, not reliant on fossil fuels. And that technology is available to us today. We can do that, and using partners with industry, both from a technical perspective and then literally fence on fence, as we want to partner with industry to take their waste heat. We can be producing much more, much higher quality and much higher quantity food for people to enjoy. And the example that Alex gives there in terms of food waste is crucially important, because not only does that mean we get more quality and quantity of calories, but it also means that the farmers get higher profitability, because they're not losing 25% of their produce based on transport or losses in the field or this. It's a hard industry. Whereas if you can improve the efficiency of it, getting more with less, you get a much better output for everyone.
But as I understood, the crucial question for your concept is, can agriculture and industry cooperate in such a way that both sides benefit? So to achieve the goal, you need clusters from industry and agriculture that work together to bring your vision to life. How can you organize that? Because industry and agriculture, it's just two worlds.
It is, but that is the job as well. That's part of our job to do it. But but actually, the collaboration between industry and agriculture is happening all the time. When you look at some of the leading technological companies over the world, they really do partner with agriculture, horticulture. An organization like Würth and the effort that they're putting into what they're doing to see this, it's necessary. And when we talk to industry about our collaboration, which is that fence-on-fence collaboration, taking their waste heat, taking their CO2, turning that into plant food, ultimately we're saying to them, you have a problem in that you are currently emitting waste heat, waste CO2 into the atmosphere, and we have a need. And we can potentially turn that waste into a revenue stream for you, or even in a worst case scenario, you're going to be creating sustainable food. So when we talk to industry, we meet open doors, and we welcome industry to continue to talk to us and other people within the space, because that's where the opportunity comes, and that's where the innovation comes from organizations like Würth and what they're doing in this space.
And it's already going on, yeah? You're already talking to industry?
Absolutely. The best example is here, right?
Yeah. Sure.
We had a visit on Tuesday again in our headquarters, where we could see this breeding station is also interesting for them to grow trees. We have seen many trees have gone, especially in the last summers, and have died off. But you need more trees now to plant, and you need them in a higher quantity and with very resilient, being resilient when you send them. So what you can do on this breeding station again is to grow them faster, in a shorter time, more trees, and with more rooting on it. So if you send them out, they have a defined height, a better rooting. So they reach you after 3 days in a DHL parcel. We did plant 1,000 trees in the last 6 months in our forests here. Yeah? So then that is what is a side effect of this. This breeding station can be used for many things. And it's really the thing, it solves an issue in a very short time. And that was in a talk to, as said before, from the company Burkhardt with me, to be honest, on a dinner. We said about what can we do. We have a problem. I cannot solve it with my team, which is also here around. Thanks for my team helping me. And Burkhardt, they said, okay, we take care about this fluidal part. Yeah, we are not the experts. And then, of course, for him, it's like how we are now in discussion, how can we implement it in your factory, in which scale, how to build it up to make it work. Because the realization of ideas is the most important thing in all the innovational part. And that's where we take a role as manufacturing company and say, yes, we take this. We help to get these things realized and not only staying there as an idea. Innovation is then an idea when it finds market, application, customers for it, right?
It sounds like a huge vision, and but you sound very hands-on, so it's really interesting. Let's have a look into the future. Is this vision, this whole organization of agriculture and industry together in these greenhouses, is it something or a tool to defeat hunger in the world, or to bring humans on Mars some food? So how is it, what's the future? What can you do with it? Mm-hmm. Not only with a small machine.
If we, or when we go to Mars, you need a controlled environment to grow projects.
Yeah.
It's as simple as that. And they're already able to grow kale in space and lettuce in space and these types of things. But on a personal level, if we go to Mars, I want us to go there because we can, not because we have to. I'd like us to address some of the sustainability issues on Earth, and maybe correct some of the mistakes of the past in terms of reliance on fossil fuels, so we can create agriculture for a generation here on Earth that's going to be able to benefit from it now, for my children and our children going forward, rather
globally.
Than... Absolutely, yeah, absolutely. Yeah. It shouldn't stop. It shouldn't. This isn't something that's just confined to Europe. Absolutely not.
Dear Ryan, dear Alex, thank you so much for the insights into the net zero greenhouse. And yeah, I'm really looking forward to taste the lettuce and to taste some tomatoes. Future positive, I think. That's the topic here. And yeah, have fun and thanks.
Thank you very much.